Hello and welcome to Module 8, Lesson 1. We're going to look at simplifying radicals today, and we're going to break this into two videos because there's a lot in this. So you'll only have one assignment, but it's going to be broken into two videos for the instruction. So simplifying a radical using perfect squares. So we're going to list all the perfect squares of numbers 1 to 15. So what does that mean? Let's go ahead and get started. 1 squared is 1. 2 squared is 2 times 2, which is 4. 3 squared is 9. 4 squared is 16. Pause the video, write them out. You need to know these numbers really well, right? Hopefully you've done this. You see the rest of them pop up there. These numbers, like I said, you need to know these really well. You're going to be using these a lot. So simplify the square root of 25. Well, that's 5. Most of you probably know that, but let's take a little closer look at it. The square root of 25 can be rewritten as the square root of 5 times 5, which 5 times 5 is the same as 5 squared. Now the square root symbol and the squared exponent cancel each other out, which gives us the 5. Now it's a lot of extra work there that I didn't need to do, but what I wanted you to see is that the squares and the square roots are inverse operations. They undo each other. Real quick pause here. We're going to look at a multiplication property of square roots. So what we just got done with, what I just showed you there, we're going to combine with what I'm going to show you here to simplify radicals. So let's go ahead and look at it. For positive numbers a and b, if I multiply two numbers under the radical, I can split that into two separate radicals, like it shows there. So the square root of ab, I can do the square root of a times the square root of b. How does that help? Well, let's look at the square root of 50. The square root of 50, I could rewrite as 25 times 2. And then I could split that into the square root of 25 times the square root of 2. But the square root of 25 we just saw a little bit ago is 5. The square root of 2 at the end just goes at the end, and that is simplest radical form for the square root of 50. How about square root of 75? Well, that's 25 times 3. So the square root of 25 times the square root of 3, that's 5 radical 3. That's how we say that, 5 radical 3. Square root of 100, that's 25 times 4, which is the square root of 25 times the square root of 4. Square root of 25 is 5. The square root of 4 is actually a good number as well. It's 2. So 5 times 2, 10. Square root of 125, you're getting the pattern, hopefully. It's 5 radical 5. Square root of 150, it's 5 radical 6. Let's take a look at a different one that doesn't use 25. Square root of 72. Let's look at the perfect squares that I had you write down at the beginning. Are there any of those numbers that divide evenly into 72? Okay, hopefully you see that 72 divided by 2 is 36, and 36 is one of our numbers. So I can do 36 times 2 and get the square root of 36 times the square root of 2, which is 6 square root 2. Now there is another method, and actually in my in-person classes, this is the way I teach it. I think it makes a lot more sense than what I just showed you, but if you like what I just showed you, you can use it. So the factor tree, I'm going to take 72 and I'm going to break it down into its prime factors. So two numbers that multiply to 72 are just 2 and 36. You could choose another option or other combos. It's okay. So 2 and 36. 36, though, can go further. That's 2 and 18. Well, 18 can go further. That's 2 and 9. Well, 9 can go further. That's 3 and 3. At this point, I can't break any numbers down any further. So I'm going to circle my prime numbers. That's the 2, the 2, the 2, the 3, and the 3. Now I'm going to rewrite 72 using all of those circled numbers. So there's 2 squared, so that's 2 2s, a 2 and a third 2, and then 2 3s. Now, why did I write them like that? 2 squared times 2 times 3 squared. Okay. The square root of 2 squared, remember the radicals cancel. The radical and the squared cancel, and I'm left with just a 2. Square root of 2 doesn't cancel anything, so it's just square root of 2. The square root of 3 squared, the radical and the squared cancel, and I'm left with 3. And notice where I put it. It goes on the outside of the radical in front of. And then I can do 2 times 3, which is 6, radical 2. It's the same problem we just did in the previous example. Using a different method, it gets you the same answer. So whichever method you feel more comfortable with, use it. Okay, we're going to stop now. Next video, we're going to take a look at a few more examples using this idea.